Hello. Today we have a lab set up here to explore the ideas of dynamics and Newton's forces. What we're going to be testing today is we're going to be testing for the force of friction using this lab setup. So what you need for this lab setup are 5 objects. An object that you would need to use to slide down the incline, a protractor to measure the incline, the angle of the incline, a scale to measure the mass of the object, any piece of wood or any track that can help to make an incline, and books or any other object that can help keep the incline raised. So the first thing you need to do is you need to mass your object to get some important information. The first important information is obviously the mass, so we're going to mass it. Once you have the mass, write it down somewhere, keep it noted. Next, what we're going to have to do is we're going to have to put the object onto the incline and test to help test for the friction. So what you do is you begin to slowly raise the incline until the object just begins to move. That's when force of friction, the static force of friction begins to act upon the object. So I keep it there, and so we're going to keep some books here to keep the incline raised. Next, what we're going to do is we're going to use the protractor to measure the angle of incline, which would be our second and last important information that we need to use to solve for the force of friction. Alright, so that's it with the procedure. Next, we're going to have to move on to the math and the calculations portion to help you find the force of friction.
So for the information, for our mass of the object, we got 0.0115 kilograms. And the angle of inclination, we got 18 degrees.
Alright, so once you have all the information, what you need to do is you need to set up a free body force diagram to help you visualize and determine what components you need to find to solve this problem. So what you do is you give a dot for the object, just make it a point like dot, so then you can draw the forces on top of it. So obviously there's a force of gravity, force of the earth on the object that is acting upon the object. There's a normal force, which is a force that's perpendicular to the surface of the incline, and there's a force of friction that is actually acting upon the object, keeping it up on the incline. So what you do is you have to make a sort of an XY axis coordinate, so you are able to break down the force of gravity to help solve for the force of the normal force and the force of friction. So this is where the information we found earlier comes into play. So the angle of incline that we got of 18 degrees is 18 here, because if we imagine the incline to be like this, coming this way, 18 would be here, and so the other the portion of the 90 degrees, that would be here, and so the other would be here. So the angle of incline is actually 18 right there as well. So once you have the free body and force diagrams, you can use those components to help you set up formulas and then solve. So here are the 3 important formulas we're going to need to use to solve for the force of friction. The first one is the force of gravity times cosine theta will help you get normal force. Then the force of gravity times sine theta will help you get the force of friction. And lastly, we need to use the formula with coefficient of friction times normal force will help you get the force of friction. So if you want to know where we get the cosine and the sine from, if you have a look back at the free body force diagram, the component that is cosine, which would be the adjacent right here, matches with the force, the normal force, and the one that is opposite, which is sine, matches with the force of friction. So that is why the components you have lined up here on the formula work the way they are. So using these formulas, we're going to plug in numbers and we're going to solve for the force of friction. So first what we're going to do is we're going to solve for the normal force. We're going to use the mass of the object, which is 0.01155 kilograms, and we're going to use the the acceleration of gravity, which is 9.8, times the cosine of our angle of inclination, which is 18 degrees, to get you the normal force. And what we get is 0.144. Then we move on to the force of friction, which we have force of gravity times sine equaling the force of friction. So once again, just like before, 0.0155 kilograms times 9.8 times sine of 18 this time will get you the force of friction, which in this case gives you 0.047. So with these two variables, with these two forces determined, now we can use the last formula from before to solve for the coefficient of friction. So the coefficient of friction coefficient of friction times the normal force will give you the force of friction. And so if you bring the normal force over to the other side, coefficient of friction equals force of friction divided by the normal force. Once you plug in the numbers, you get a coefficient of friction of 0.32. And you know this is correct. Well, you can assume that it's correct at least because it's in a range between 0 and 1, which all coefficient of frictions have to be in. Thank you.